Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're going to be talking about the term upthrust. So put down today's title, it's going to be upthrust. Right, let's get straight into it. So let's say we have a fish tank over here, and inside the fish tank we have an object. Yes, this object is right bang inside the water. Let's talk about the pressure acting upon this object. So we know that there'll be some pressure from maybe the left-hand side, yeah, and there'll be some pressure from the opposite side over there. So there's pressure acting on both sides here. There will also be a pressure from the top, but there will also be a pressure from the bottom. Right, guys? Right, so as you can see, there'll be different pressures acting upon the object, between the top of the object and the bottom. So look, the pressure at the top will not be the same as the pressure at the bottom. Why? Because the object is at different heights at those 2 points. We looked at in the previous lesson that pressure is equal to the density times by gravity times the height. So look, it's at different heights. The top of the object is going down to there. The bottom part of the object goes down to there. So they're two different heights, guys. Yeah. So if you look at that, it's going to be two different heights over here. So this height over there and this one over there. See, we're at two different levels. So that will obviously cause a pressure difference. So there will be a difference in pressure between the top of the object and the bottom. There will be a difference in pressure between the top of the object and the bottom. That difference in pressure between the top of the object and the bottom will cause the object to experience a force. That force will be known as upthrust. So let's put that down in words. So the difference in pressure between the top of the object and the bottom will cause the object to experience a force. And that force is going to be known as upthrust. So the difference in pressure, so let's just say, so obviously it's the pressure over here. So the pressure at the top. So let's call pressure at top. And if we look at the pressure at the bottom, yeah, so there we go. So I've drawn it now. The pressure at the top and the pressure at the bottom. If there's a difference in pressure, that will cause a force to be experienced, guys. So the force is upwards here, and that will be known as upthrust. That would be known as upthrust. So the difference in pressure between the top and the bottom of the object, that is known as upthrust, guys. So there you go. The object will now experience a force, and that force is called upthrust. Okay, so you can also calculate the upthrust by doing the following. Let's say, for example, we have a beak of water and we fill up to the brim. And then we take a giant rock. There we go. Here's my giant rock. There we go. And we throw it into the water. What's going to happen? Okay, so obviously this is the before stage. And then the after stage is... Right, and here's the after stage. You throw the rock into the water right now. Obviously, some of the water will be displaced. So some of the water will come out. Okay, so obviously you drop it in there. Hopefully you've run a bath before, you've jumped in the bath before. The water will be displaced. So some of that water gets displaced. So the water is displaced. Right, okay, so the water that is displaced, let's say we were to collect that, guys, and we were to find the weight of this water. So if we were to find the weight of this water, guys, so the weight of water displaced, yeah, so the weight of the water displaced, guys, that is also equal to the upthrust. So the upthrust, guys, is equal to the weight of the water displaced. So it's equal to the weight of the fluid displaced. I'm putting the word fluid down because it might not be water. The weight of the fluid displaced. Yeah, and if you've forgotten how to calculate the weight of an object is equal to the mass multiplied by gravity. Happy with that? So upthrust is also equal to the weight of the fluid displaced. If you chuck a rock in there, you collect the water which is displaced, you weigh that, that will be equal to the upthrust. Alright, so let's move on to the following. Floating and sinking with upthrust. So floating and sinking with upthrust. So let's say, for example, we've got three different scenarios though, A, B, and C. The first one, let's say right now we have the upthrust right now over here is going to be quite large and the weight is quite small. What do you think the object will do? Will it float or will it sink? Well, because the upthrust is greater than the weight, the object will float. So this one will, yes, move to the top. So this one, it will float, guys. So this one, it will float. The next one, let's say, for example, now, so let's put that down. So this is upthrust greater than the weight. Okay, what about the next one? Let's say, for example, we've got the upthrust, yes, is equal to the weight. What's going to happen now? Well, now there will be no resultant force. The object will stay in that position, so it will remain there. So nothing happens. So this is going to be nothing. So it stays in same position. So this is obviously when upthrust is equal to the weight. So when upthrust is equal to the weight. And last of all, guys, well, you can guess what I'm going to explain now. So now we have, let's say, for example, the upthrust is quite small. Yeah, look, it's a smaller arrow, but the weight is quite large right now. So obviously now we're going to have, right, so the weight is greater than the upthrust. Therefore, if the weight is greater than the upthrust, guys, what's the object going to do? It's going to sink to the bottom. So there we go. This one will sink over here. So make sure you understand the relationship between upthrust and weight in terms of if it floats and sinks, guys. So clearly, upthrust is greater than weight, it will float. Upthrust is equal to the weight, it will stay in the same position. The upthrust is less than the weight, obviously it will sink. So 3 different scenarios, guys, 3 different scenarios. Okay, so the last bit about floating and sinking is going to be about the density of the object. So in order for an object to sink or float, we can also refer to it in terms of the density. So the density of the object is also important. So basically it's this. If the density of the object is greater than the density of the liquid, it will sink. So right now, guys, let's say, for example, this one density of this is going to be 1 gram. So the liquid is 1 gram per centimeter cubed. And let's say this object over here is going to be 2 grams per centimeter cubed. We know that this one will sink to the bottom. So this one will sink, guys. Okay? And what about the next statement? Oh, let's put it down there. So density of the object is greater than the density of the liquid. It will sink. Right, and the next one's going to be if the density of the liquid is greater than the density of the object, therefore it will float. So in this one, it will float. So that could be in this example then. Let's just say, right now, same thing again. So it's the same density of the water, 1 gram per centimeter cubed. But let's say this now is going to be 0.5 grams per centimeter cubed. So clearly you can see in the second diagram, 0.5 is less than 1. Therefore, this one will float. So this one will move up and it will float. Okay, so this one will float over here. Okay, right, easy stuff, guys. So we talked about quite a lot today. Let's have a quick recap from the top. So scrolling up right to the top, we did upthrust. So the upthrust. The upthrust, guys, can be looked at in terms of the pressure acting upon an object. So if you look at an object inside water, the pressure at the top is not equal to the pressure at the bottom. That pressure difference, guys, is equal to the upthrust. Right, so that pressure difference between the top and bottom of the object will cause a force to be experienced by the object. That force will be known as the upthrust. Scrolling down, we then said the upthrust was also equal to the weight of the fluid displaced. You were to take a rock, throw it into a beaker which was filled with water. The liquid that is displaced, if you were to find the weight of that, that will be equal to the upthrust, guys. So that will be equal to the upthrust acting upon that object. So it'll be equal to the upthrust acting upon the object. And then we talked about floating and sinking with upthrust. We said that when the upthrust is greater than the weight, it will float. When the upthrust is equal to the weight, it will remain in the same position. For the weight to be greater than the upthrust, therefore it will sink. Right, last of all, in terms of density, we know that if the density of the object is greater than the density of the liquid, it will sink. Right, and if the density of the object is less than the density of the liquid, it will therefore float. Right, and that's it for another session in CeerazzleDazzle Physics. Make sure you watch it again and make sure you write down the notes that you need, especially the key terminology. Make sure you like and subscribe to my videos and comment below if you have any queries. I'll do my best to answer them. Good luck in your studies, guys. Ciao, ciao, and goodbye.